All right, I have a few more words for Matthew. Not many though. Particularly human, fond of hard to articulate things, platform and engineering lead at DataJoint. Talk to us about TDD and a little bit AI.
Sweet. Yeah, so I'd say I'm going to share with you guys a particular kind of TDD, which is this double loop TDD. And the point is that every tool has the things that it gives you. And one of the things that this particular tool gives you is the ability to surface design decisions during an implementation. So this is me. Rylan kindly read this slide for me, so I will sit here in silence. So the general idea here is in the context of today's Brave New World, there's a lot of conversations around understanding being shifted to the review or being deferred. But at the end of the day, we could always copy and paste from Stack Overflow. So the ability to ship code we didn't understand is not a novel one. It's just one that is landing on people's plates a little bit more frequently. So choosing to forego understanding or choosing to make a design decision, it should be informed and deliberate. You can choose not to, but it should be an informed and deliberate choice. And some techniques are better or worse at raising the deliberate nature of the design decisions that you're making. So if you look at code in general, there's I want to think about this as like precision and accuracy, or I want to think about this as in the particular code is as fine-grained and nuanced as it gets. This is what is happening. You describe it, and on the coarse grain you have PM speak, which is the user wants a button to do a thing, and then sometimes the code can be documented perfectly, and sometimes it can articulate perfectly that the button does the thing. But sometimes there's this unknown thing in the middle that is not well documented, well tested, good code, and it is not actually fully captured in what the PM may have left you with, which might just be a recording with some particular client at some point. Like the requirements here are odd. So this middle is where the design decisions can happen, and this middle is where you doing okay?
Yep, you're good.
Okay.
I'm trying to go full screen and I can't.
That's okay.
Oh,
So
you're not recording? Oh, yeah.
there are a lot of tools where like LLMs will allow you to expand the surface area of things you don't understand and decisions that you do not make, which again, this is not a judgment call. This is just a thing that we can be deliberate about. You want to use the tools to your fancy. If you want to shrink it, if you want to surface it, if you want to make this middle smaller or larger, those are things that we can choose to do. So I like units. I think what's really cool is every time you have a different unit, you can have a different axes on a graph. So there's this two-axis thing that is correctness and plausibility that don't quite intersect with each other except sometimes. So the thing that is strange about a lot of the LLM generated code is that it's plausible. It looks right. It's well formatted. It's not like this 17 lines of white space because this is the first time writing code and you just didn't want to see the other things. That's how I wrote code when I started, and that's how people knew. I sat down and said, "My God, this guy loves this white space." I'm like, I like focusing. So these are not tells anymore. So it's plausibly correct. But the question is like, is it correct? And those are two different axes. And the gap between them is whether or not we have made these decisions, have even surfaced these decisions, or if this illegible middle is something that we're considering or not. Are we trying to shrink it or grow it? Another one, tactical versus strategic, precision versus accuracy. The example here is if we have a photolithography machine and we have nanometer level precision and plus or minus 0 meters, we make a computer chip. But if we are not in the right ballpark, this machine will tramp stamp your colleague by accident, and that's fine. You can make a great living doing that. It's probably not the most cost-effective way to do that, and it's probably not what you told your investors you were going to do with a photolithography machine. They're probably going to be expecting computer chips instead. So it's important that the tactical approach and the strategic approach are aligned. Very frequently, you hear people and they'll say, well, we're strategically aligned. Now we just need to be tactically aligned. And that's like a really comforting feeling when you're working with somebody saying, we know we're going in the same direction. We just need to agree on how we're doing it. And we're finding a very strange place where we are tactically aligned with these LLM tools and strategically completely disaligned. So again, it's two different axes, and a really fun way to, as soon as you put a unit on the thing, you can have a different axis. There's another talk that I really particularly like. Maybe everybody's favorite. This isn't the WAT talk, but the ideology one. He goes over this known knowns, unknown knowns, and all the. He points out that the unknown knowns are the ones no one talks about, and that's what he calls ideology. This is Gary Bernhardt has a talk. I recommend everybody watch it. What I like about this is back to the hard to articulate things is there are things we believe, there are beliefs we carry, and there are things that we want to imbue in the work that we do that we may or may not be able to articulate. And if we are increasingly communicating with written language, it's very important to be able to surface those and to learn what the hard to articulate things are. So in the notion of automation, I've been thinking about this book that I read way too many years ago, so forgive me if I'm getting all of the metaphors here wrong. There are a few different, this book's a tragedy, Brave New World. There's a fully optimized, automated, sedated world, and you can be conditioned, or you can know something's wrong and go along with it anyway, or you can be a Luddite and John the Savage rejects all the tools and he ends up isolating himself. And then you have this notion of Mond, who knew the world before and has read the books and he knows the ways. And to be clear, this is not a call to action to be Mond. This is, again, just to say there are different tools. Sometimes it works, and that's great. And sometimes it's really important to carry in techniques that are not necessarily shared or celebrated. So it's about surfacing the decision and responding instead of reacting to what you're doing. So that's what I'm trying to do with these tools. So yeah, back to the strategic. These things generate text. Okay, if you are, this seems obvious, but you have to say the obvious things. If the machine vomits words, all you can do is steer where it points and the way that the words might come out. And that seems obvious, but that is tactical. You can say speak in Spanish and it will, but you can say be strategic and it'll tell you okay, but it just changes the words that come out of it. The thing doesn't think, it just changes how the words come out. It's not really that different here. In the Brave New World, there's this beautiful drug called Soma. I just put this here because I thought it was beautiful. I'm gonna let you all skim it.
Oh my goodness. That expresses doubts.
So at the end of the day, if you have any anxieties, doubts, fears, any problems, that's okay. Just wipe over it. And this is what I see cultural shifts on what we're trying to do with our tooling. And a lot of the cultural shifts are, it's fine. And in some use cases, it is. And in some use cases or scenarios, it is not. And it's very important to be deliberate. So again, there's no judgment in any direction here. It's just, let's be deliberate with our tools and let's learn what some of the tools are. So what are some of the tools? TDD is a particularly useful one in a lot of different ways. There are different flavors of TDD. There's one that I like to call test first, weak. and that's the one that a lot of people do. There's one where you actually write the test first. It's very similar to test first, wink, but you actually write the test first. There's more than just writing the test first is seeing it fail. So there's another step on top of that. You can't just write the test, then write the implementation. You write the test, you see that it fails, it's red, and then you write the implementation and you see that it turns it green. That seems obvious. It's not. That is a technique and it goes a long way. There's this other magical part of the loop, the red-green refactor. People often forget this particular thing. So the red-green refactor means once it's green, then you have a moment of reflection and you choose, is my implementation ideal? Are there things that I want to change? Are there things that I want to note? And that moment of reflection is really, really important. And a lot of the press one. I've pressed one too many times. Press two. This turns into I'm less worried about the implementation. I'm more worried about removing the moment of reflection. And that's the thing that I'm just wanting to surface as a choice. We can do this, but we should be deliberate about it. There's another kind of TDD, which is double loop. So the idea is, so there's outside in with fault isolation. So if you have an end-to-end test, it's hitting the outermost layer of your API and it fails. In TDD, the step that you want to take is, what is the tiniest change that I can make to not pass the test, but like regress the error message of the test, or to get me to the next assert in the test. And with this double loop TDD, instead of doing that, you say, what is the single most isolated failing test on the inner layer I can write? And then I will progress that one. So you progress the outer loop failing test with inner loop failing tests, and the inner loop failing test can be progressed by code. And what this does is it allows for a much different layer of not just end-to-end testing. You don't have to do bottom-up design where you have the units and then you staple them together. You can develop them in tandem. And you do have regression protection at many different layers of abstraction. And this is pretty exciting when you refactor. If you only had tests at end-to-end, refactoring away from those tests mean you have entirely untested code after refactor. So this enables safe refactoring. Here's the word for it. So outside in with fault isolation, also TDD, aka double loop TDD. We like to call it. I don't know if you guys have heard that before, but it's where I'm from. That's just like commonplace. So, yeah. Okay, so to test this, I wanted an experiment. I wanted a project that was complex enough to raise dissonance in design choices and simple enough to implement twice since Saturday when I told Rylan I was going to do this talk. So the experiment is I wanted a webhook relay. So everybody's played with these. Sip of water here. You can have GitHub pull requests, GitHub issues. You can have Stripe payments. You can have Twilio SMS responses. Anything that comes in as a webhook is going to hit your service. You might want to do something with that. You might want to post to GitHub for one thing. You want to send an email for another. You might want to pager duty with another one. So this thing in the middle is what we're building. It's a two-pass test here. We have core behavior. We're gonna implement the core behavior, and then the second thing we're going to do is have a second tier. Requirements always change, so we implement core behavior. So we have one notion of what an design and architecture is that we want, and then when this changes, we have new requirements. Does our architecture hold up? Can we withstand things? What works? What doesn't? And I did it twice. I tried to do it 3 times. Once where it was like, no TDD, nothing at all. But I ended up prompt injecting myself at every corner. It was like, but your Claude MD says you really like TDD. And I like deleted that. And I started again. I'm like, damn it, now do it. And it goes, well, your directory is named double loop TDD, so I guessed it would be. Darn it. So I couldn't. There's so many ways that you could actually like step yourself into this, like all of the little things you compound. So what I ended up with was a very low touch red-green TDD, proper red-green TDD, and then one with this double loop design where I was much more interactive with it. So there's a lot of moving variables here. This is not to say one is better than the other. It's just a fun thing to show the difference here. Here's the results. Both of them fully implemented the spec, and the second one I ran out of time, so slightly got less implementation, but they're almost identical spec fulfillments. So we have almost 470 production lines of code, B 170. So production files, way more, production files, way fewer. The test coverage in assertions and lines of tests is almost identical. That's where a lot of the attention was focused, this is test first, the coverage in what is asserted, how does this work, how do we want to construct how do we approach the spec and turn it into a codified assertion that the spec is real. This I was actually surprised by this, that we had, I thought I would have way more tests. We had the same number of tests. I mean, like 530 and 600 are about the same. The production code is significantly less, and I was astonished by that. I expected it to be more, but it turns out when you iterate on different designs at every corner, there's less cruft, and that just falls out of it. So that, I think this is fun. And then there was no unit level tests on the red green because everything was outside in. And then there was on the double loop. The file structure looks something like this from red green. And a lot of, just to be clear, like a lot of this is done with Claude. So this is not me doing this twice. This is a like let's let these tools that stochastically parrot things for us drive, but how do I involve myself in the loop, and do I want to? So on the A side, red green, we have a ton more files. You can see like the sources and destinations. There's really good file structure here. On the B side, the double loop, it's pretty flat. I actually like the file structure in A better. That's an easy refactor. You can move files and rename them. That's fine. I just thought this was interesting. We had one test file that was massive in A, and we had well-structured, these are the unit testing layers and the end-to-end testing layers in B. So I thought these were just interesting artifacts that came out of the experiment. So that's one thing that was fun. We have the same feature, two different APIs here. So the outside in, we create a router. And this is like a very naive approach in all of this. I'm not trying to straw man here. I'm just trying to be honest about how the experiment happened and what I thought was interesting coming out of it. We have a router. We define routes on that router. We use that router to create a relay. The relay is then called with the headers, and that was what outside in told us to do. When we did the double loop, for some reason, I was much more involved. I didn't specifically tell it to do one thing or another. Resulted in a much simpler interface. We can define when GitHub pushes to main, post to Slack. This is the exact same thing on both of them. I just thought that was kind of interesting how different the resulting API was just from the techniques that were used. Extensibility. What happens if we want to add Stripe? This was actually almost identical. A design choice that was raised through the implementation of this was, do I want router.add, or do I want to expose sources as a dictionary, as a hash? I liked that. I told it to do that. So the only real difference here is router.add versus relay sources stripe equals. You can shovel it in. Well, I guess we can't, it's a hash. So these are the only difference. But that was a decision that was raised to me. I made one instead of the other. This might be an arbitrary decision, but we did choose to make this decision here. One thing that I thought was fun was, because of how B was implemented, we just have syntactic sugar to also do this dot transform. And we can pass it a lambda, and it will automatically construct an anonymous class for us that does this. So I thought it was neat that because of how we drove the design, there was an inner layer of more of an API that was exposed to it. So I thought that was particularly noteworthy. There were a lot of different design decisions that came up. When I started this, the obvious design decisions up front were actually only this last one. We have n sources and m destinations. So when you have n sources and m destinations, this is like a classic, we have 30 file types, and we want to convert any file type into any other file type. This is a combinatorially expensive problem, unless you have this beautiful thing that is a canonical event that sits in the middle. So you say like, or a canonical file type that sits in the middle. You say read a file, put it into generic. Every file transfers to generic. Every file can be generated from generic. And that was the obvious solution to do up front. And when making this, that was the only design decision that came to mind, was, do I want to use this canonical event or not? That was actually the only design decision that I think we actually got wrong from doing in the double loop, doing red green versus the double loop. So who's consuming this? Does IO matter? None of these were described in the spec. These were all decisions that came out and we could choose later. But it was arbitrarily chosen with the Claude-driven red green, and very deliberately chosen with the double loop. I'm going to go back to this n by m one. I thought this was unique because it turns out when you're actually implementing or using a webhook, you care deeply about the shape of the source of the event and deeply about the format of the output. So this canonical event in the middle is way less useful than it is for patterns like file mutation. For something like a webhook, you actually just want a lambda where you can dig into the size, the input, and turn into the output for the target that you want. And that's the usage of that. But that wasn't obvious until there was much more interacting with the code base at different levels of abstraction. So that I just wanted to raise that. And there's a ton of little ones that come out. Some surprising bugs that came through with a little audit after this. So, classic rescue all versus very specific. We're rescuing rate limit errors, delivery errors, and we can do very specific things with them. If something errors, it's actually a bug instead of all errors are swallowed. The HMAC verification, if you get a webhook coming in, sometimes it comes with a header and it tells you, has this been a tampered with payload is the question. And the outside in red-green implementation said, well, shoot, we'll just generate a JSON from this payload and HMAC it. But that breaks because it might have different white space before and after. So it's really important that you check the HMAC against the actual original payload instead of just a JSON formatted response of the data that you're holding. So this is a surprising bug that came up just from not inspecting at every corner. A memory leak. So the shove the payload in messages. What happened? Like, this is going to explode in exactly 3 weeks from now, right? When you have a production outage, you're also going to have, so this is the kind of thing that sneaks up on you. But this didn't happen because the other implementation, it wasn't even in the spec to have IO. It wasn't in the spec to actually send an email, to actually post to Slack. It just said, I need to be able to, be represented in this way. So there was just no IO for the second one. So there was no way to have this memory leak. So here are some unconfronted decisions. Should the errors be handled? Which ones? They're not things I'm pinning on LLM. They're things I'm drawing attention to. Like these are design decisions. They're either confronted or they're unconfronted, and we have techniques for either confronting them or not. And it's important to be deliberate about what context is the code that I'm working on. Do I need to confront these decisions? Should I use techniques to confront these decisions? That's all. And then, often I found it astonishing how this is the thing that you tell yourself, but like it blows you away every time when you really see it, just how much less code was actually written when you're a little bit more rigorous with some of these techniques. The fact that I had so much less production code and an identical amount of testing code, arguably the same implementation, that just really stood out to me. I think every line of code has a cost. Is a cost of writing, a cost of maintenance, a cost somewhere. And I like that to go down. I don't know. So the problem with the metaphor of this whole like Brave New World thing is that it's pretty dark. It's a tragedy. Everybody, runs themselves into the ground. And I'm too optimistic for that. I'm reading this other book called Station 11. Fantastic book. Don't spoil it for me. I'm not done with it. But there's this beautiful thing. There's a
TV series. If you,
I don't. Hey.
Yeah. They're very different.
Instead of everybody having their staunch belief that they trudge into this dramatic end, this is part's not a spoiler. There's a post-apocalyptic world where some people remember the past and some people don't. Some people are too young. Some people have similar responses. Do I bury it or do I carry it with me? And there's this traveling symphony that believes survival is insufficient, and they just travel the world and they perform Shakespeare, and that's what they're doing with their life. And one of the main themes of this book is conscious grief. And I'm not trying to be dark with that. I think like grief is an important thing. Grief is like a thing that you have passion for, and you're struggling to know where to put that passion, and to be conscious of that it's a deliberate thing. So that's not offered in Brave New World, but something that I've felt a lot in this other book. So these are all choices available to you. again, there's no judgment in what people are doing. There's the call to action here is only you have options and you can be deliberate with them. And I think an informed life and informed decisions are healthy and only possible if you have them. Yeah, that's where this is me, a couple links to stuff, books, good stuff. The end.
Excellent. Cool. How do you tell Claude to do this?
Very patiently.
I mean,
No.
how did you direct it to say do double,
Yeah, so most LLMs will be trained on very broad material. So in my personal Claude MD, I'll say my preferred style development is test-driven development. Most specifically, double loop TDD, where an end-to-end test is not addressed except by an inner unit test, and that inner unit test, like I will explicitly state it out, and it just doesn't fight me. So I read every single line of code. I treat it like a pair programmer when I work with these tools, and I found that actually really frustrating for like the first bit of it. One of the most rewarding things to me about pairing is like the connection, and that's just gone. Yeah. So there's like I want to share and I want to teach and I felt so much loss there. It's like if you just there's this frustrating employee that like I told you this already.
yes.
and it's not pairing. The techniques are similar, but I had to fully leverage it into saying like this is an educational tool for me. This is a tool that allows me to articulate my values. I was sharing earlier. I have my own ideology book based off of this talk, and I encourage everybody to have some form of this. So I say these are hard to articulate beliefs that I hold, and I'll say, dear Claude, read this book I'm writing. It'll read the book. I say, dear Claude, read this repository, or look at this particular Git diff, or look at this refactor. And I'll say, where do these pieces? Where does this book and these code changes or this work align? Where do these code pieces or changes have dissonance? And where they align, I feel good. And where they have dissonance, either the code needs to change or I'm missing a chapter in the book. And that helps me identify what the unknown knowns are. That helps me identify, like, this is a belief I hold, and I haven't put words to it yet. So I'm trying to use these tools primarily for my self-education and choosing where to apply rigor. Does that answer more tangibly and specifically?
Yes. Yeah.
Okay.
Yeah. I feel like I'm also often just training Claude to do things my way.
Yeah.
But you're being very deliberate about that. Like, what is my way? Questioning.
Yes. Yeah.
Is that something you could share?
Maybe in like a few months of iteration, but yes.
Type it up in a typewriter.
No, I expect to. Yeah, I expect to.
So is the flow, like, are you interacting in those loops? Are you, who's writing the tests? Like, are you writing the test, or you're like, Claude, write a test? And then you're like, I'm interacting with this test and like, this is a good test or this is a bad test, and telling Claude that it's a good test or a bad test.
Claude will say, tests first. Here's a page of tests.
Okay.
And I say, what are you doing, man? One test. And then we get one test. And then I go like, is that even what we want to do? And so I'll iterate it. I'll just like a pair. I'll iterate on what I want the test to be. Okay. And then I go, yeah, that's driving the direction that we want to go.
Okay.
And it fails. And then he tries to implement. I go, come on, man, we need an inner loop. Oh, you're right. You told me that 4 times. And then we get an inner loop, and then that one fails. Okay. And then when that one fails and the outer one didn't, then I go, okay, why did this inner loop test not progress the outer loop? And I use that as an introspective moment of like, was this the right inner loop test? Was this the right thing to progress it? So what I don't like about these tools is when agency is taken away, when decisions are taken away. Right. What I love about these tools is it's like chess master. I get like a rigorous, brilliant, witty, insightful, like the thing I care about, I get wicked sharp feedback on. Right. And I can develop on that. So I use it exactly I would with like the brightest engineer that also doesn't know that we're on a budget. Right? Like whoever Like that's how I'm treating these things.
Yeah, that's a good perspective.
Yeah.
And like, so what is your perspective on like, why were there fewer lines of production code in the two?
I think it's an artifact of the process.
Okay.
I do. I think when you
And you think that that would play out in it, like, just by adhering to that process, you think that would be the outcome most times?
I have observed that be the outcome when I am more involved in the process.
Okay.
And these machines spit words.
Right.
So if the words they're spitting are append, you're gonna have a ton of lines.
Right.
If the words they're spitting are here's a net neutral or negative diff that also achieves the same thing, then like if you encourage it to have like negative or net neutral diffs at everything and review every piece, then the words they're spitting are proposed changes instead of appends. And that can result in a smaller thing. Yes.
Yeah, that's cool. If this is reductive, let me know. I just want to understand specifically a double loop. So
Yeah.
is it unit test is loop A and end-to-end test is loop B?
Yeah, so as a for the sake of this, there were two. I'll repeat the question because no one's going to watch this recording. Are the unit tests loop A and the end-to-ends loop B? There was an experiment A and there was an experiment B, and the experiment A was purely red-green. Experiment B was using the double loop technique. So to sort of really drive into what the double loop technique is I will look at a feature and I will say, this feature doesn't exist. Let's write the highest level end-to-end test. So this is the outer loop. So the highest level end-to-end test will say, when I have a GitHub push event to main, then Slack receives a message that says who pushed it. That's a very, very big thing. I can implement that certainly with bugs, or I can have a failing outer loop test. And if it fails because a object isn't defined, a namespace can't be imported, and assert is broken. So any part of this test progression can't happen. What I will do to progress the outer loop is not write code. What I will do to progress the outer loop is try to identify where in the stack I might want a unit test, and that's where I'll define an inner loop.
It sounds very familiar. Thanks for the explanation. It sounds very familiar to the entire book of growing object-oriented software guided by tests. Okay, good.
Yes, yes.
In Java,
yes.
that don't let that stop. Great book. So the second, like, sort of unrelated question though is
time out.
Yeah, go ahead.
Lumi, if you watch this, he said it sounded like Grabbing Object-Oriented Code Guided by Tests. It's that book I recommended to you that you almost certainly haven't read yet. Okay, continue.
Is when you get down to writing unit tests.
Yes.
The idea of generating like where do you start and where do you stop fuzzing?
Yeah. This is its own world. Have you seen or have you watched the talk "Don't Mock Me" by Justin Searles?
Probably.
Okay, this talk was written as he read this book, and it is probably one of the best embodiings of exactly this technique. And the general idea is, if this is less his words and more mine, if you can stomach the two failing tests and have the attention to know which one you're paying attention to, it's fine to have two fail. If you can't, then you can stub out. So one approach is to have two failing tests to acknowledge it's incomplete, and then progress until you have zero failing tests. And then the other approach is to have this outside failing test that is passing with a ton of mock and stub fake implementations, and then you slowly swap out the mock and stub fake implementations. Either are completely valid. I think it's more temperament and your tolerance for managing multiple layers of failure.
I mean, just with the ability to vomit.
Yes.
Words,
Yes.
Right. There's like my initial reaction when you started to give a talk was, this sounds like a repackaging of the taste or the preference argument. Like,
Sure,
you know,
sure.
developing that. But like hearing you talk more about the ideology, it's more than that.
Yeah.
Right? Like it is a deterministic
It's a technique, you know?
technique.
Yeah, and there's a million techniques, you know? One technique is like press 2, right? Like fully implement it, but it's just there. I'm not trying to.
You know, some days it's all about pressing too. Well, but it does depend on context, right?
It does. It's
If
not.
if my goal of invoking Claude is, hey, I need a bunch of like sample, like real looking data in my application in order to test this, like in order to like do like a,
Yes.
a performance benchmark. I don't give a
Right.
shit. Right?
Yes.
Like there's no design decision there. Like
Nope.
if it works and the data is there and like I can do stuff.
Completely.
But yeah, like because you're right. It's like you tell it to do something, it just goes one shot and does the whole thing, and it's very attractive. But I did spend Monday like, look, you wrote a bunch of tests that are like, we can share setup, we can do this thing, like we can
Yeah.
yeah. But
Feel like I might not have answered your question.
No. The only other thing I would say is, what's the appetite for a gem that buzzes?
Yeah.
But that's another.
You tell me.
But for like the outer loop, it seems like there would be a good amount of value in the, like what you describe as your first test. Like I get a webhook from GitHub. Like there's a lot of information happening.
yeah.
Where like an LLM would be like, I know what a GitHub page, like
Yes.
GitHub webhook page
Yes.
load looks like,
Yes.
and that gets you really far very
Yeah.
fast for like that outer level of testing.
Which is why I need that inner loop to say, like, are you threading this whole thing through, or
Right,
are you
right.
being deliberate at each corner with
Right,
it?
right.
And like, I'm shipping this code, I'm putting my name on it. I need to understand what's happening at each corner, and how do I. So a lot of this is just techniques for like not deferring understanding to the PR review, even if the PR review is the LLM wrote code and I'm reviewing it. If I am not deferring understanding, I'm carrying understanding with it the whole time, and that's the thing that I've struggled with large amounts of code
Yeah, I
walls.
like the perspective like you're talking about of treating it as like a ping pong pair programming session. I think that's a good thing to try that I'm gonna try to do.
Yeah.
I appreciated the metaphors sprinkled throughout, like definitely very enjoyable. I was curious, I've been experimenting more with plan mode.
Yeah.
And to some extent, it on the surface, it feels like it would get at better what you're describing, what you want, like that conversation. But it also has like a rigidity to it, even
Yes.
more so. So
Yes.
I'm curious if you tried it out with.
If I use okay, for this particular experiment, I don't want to speak generically. For this particular experiment, I in both cases used plan mode, and in the red green implemented the thing, went through, did the stuff. In the outer loop TDD, which outer loop test to write next was pretty much all that was encapsulated in the plan. Or like this is the way that we're going to march through the spec, and that was really the only thing that the plan did. So the plan was my managing attention across a longer period of time. It was to escape having a checkbook on a notebook next to me.
I always have it just write a markdown document.
Yeah.
The checkbox.
Turns out that's all that plan mode is.
Yeah, exactly. That's exactly what it is. Yes. Yeah, but you can discuss that document ad nauseum until you're ready.
Yeah.
Did you have two different plans for the?
I started with the spec. So I said, here's the first pass spec, make a plan, do it. Here's the second pass spec, make a plan, do it. So that the plan was generated in each context separately, but they were both interactively generated from the same spec.
Did they look similar?
Comparable. So pretty much implement the spec. Yeah.
Oh, okay.
Yeah.
But it didn't get into the details of how to implement the spec, given the two different philosophies.
I struggled to find a problem that was in the sweet spot. So I think that was the hardest thing for me on this one. Yeah.
Coming up with good problem solving.
Yeah. Any other thoughts, worries, paranoias?
The name of that book.
Growing, yeah, I'll post it. Growing object-oriented code guided by tests. Oh, thank you. Sorry.